I'm going to demonstrate this technique again in showing how to measure the distance to a galaxy. This time I'm going to use ESO, or take a look at ESO 378-11 in the southern hemisphere. This galaxy is a bit of a challenge since it is an edge-on galaxy and it is quite far away. This is the massed digital sky survey. We enter ESO 378-11. I take the HST to survey. I take a GIF file format and retrieve the image. The galaxy is quite far away, and at 15 arc seconds across it appears very small, so we'll reduce the size of the number of arc minutes so we can see it a little better. We set the scale to be 5 arc minutes across by 5 arc minutes. We retrieve the image, and we can see that the galaxy appears larger in the image, of course, and then we download that and take a reverse image. Download it to the printer and take a reverse image. Okay, here's our reverse picture of the galaxy. Because it's an edge-on galaxy, you can see the inner arms of the inner part of the spiral are here, and the outer arms come out to about here. So I estimate that that is the center of the galaxy. Going along major axis. It's the outer spiral arm there, or sorry, the inner spiral arm there, inner spiral arm there. The outer part goes to there. And we can just barely see that we can make that out. That's the extent of the galaxy. We now measure this. Setting that at 2.0. One 1.8. Seven. 1.9. 2.0. 1.8. 1.7. 1.9. It should be pretty well all the same. Very close. This distance is gain 20 centimeters. It's equal to 5 minutes of arc. And that's what we need. Now we need a velocity profile, and then we can find the distance to this galaxy. Here we have the rotation profile of ESO 378-11. This rotation profile is from Persic and Salucci and gives a maximum rotational velocity of 132 kilometers per second. The average arm separation we had from before, if we take the average, we get 1.85 centimeters. We multiply that times 5 arc minutes over 20 centimeters, and we obtain an arm separation of 0.4625 arc minute. We take 132 kilometers per second times 0.4625 to give us 61.05. We multiply these two together. We take the magic number 3.12 times 10 cubed, this is megaparsecs, divided by this number here, 61.05, to give us a value of 51.1 megaparsec. So we have 51.1 megaparsecs that we have measured. Tully-Fisher has measured this galaxy to be at 50 megaparsec, and if we rotational has measured this at 52 megaparsec using curve fitting and so forth. So again, we have a very close measure that are in agreement with two other measures to this galaxy.